Good afternoon, everyone. My name is Vaibhav Srivastava, MTech AI student, and today our group will present our work on delivery routing optimization using Monte Carlo Tree Search. Our team members are Rahul Ray, Gulsan, Kumar, Nath, Sovan Chakma, and myself. As we all know, in today's fast-growing e-commerce industry, delivery companies such as Amazon, Flipkart, etc., must deliver thousands of packages every day. So, in order to operate efficiently, they must determine the best delivery routes while minimizing travel time, fuel consumption, and delivery delay. However, because of traffic congestion, dynamic order request, multiple routes choices, finding the optimal route become a complex decision problem. In this presentation, we will explain about the delivery routing problem, the Monte Carlo tree search algorithm, how MCTS can improve delivery routing, and a basic implementation approach. Now coming to the slide second, we talk about the motivation behind this problem. So as we all know, the rapid growth of online shopping has significantly increased the demand for efficient delivery system. And delivery companies majorly faces several challenges, which include that is increasing number of delivery orders, traffic congestion, strict delivery time windows, and rising fuel and operational costs. So traditional routing algorithm, which we all know that is shortest path algorithm or Dijkstra algorithm, usually assume that route conditions remain constant. However, real world environment are dynamic and unpredictable. So we need a smarter approach that can evaluate many possible future routes before making a beautiful decision. So Monte Carlo tree search provides an effective way to do this and finding a beautiful solution. Coming to the third slide, let's discuss about the problem statement. So our problem statement states that the delivery routing problem can be defined in some of the following manner. That is a set of delivery locations, a delivery vehicle, a road network connecting those locations. And each road has an associated travel time or distance. The objective of our problem is to determine the best sequence of deliveries that minimizes the total delivery time, travel distance, fuel consumption, operational cost. Our problem is closely related to the vehicle routing problem, which is a well-known optimization problem in logistics. Now, coming to the slide 4, we will discuss about why traditional methods struggle in order to find a solution to this problem. So traditional routing algorithms work well for small problems, but they struggle when the number of delivery locations increases. And this happens regularly because of many problems. That is, the number of possible routes grow exponentially. Second, the traffic conditions change frequently. Third one, different delivery sequences produce different results. And the last, time constraint further complicate planning. So because of these factors, evaluating every possible route become impractical. And this motivates us in order to find more intelligent search technique, and we found out that Monte Carlo tree search is the best one. Now coming to the next slide, we will discuss about the introduction to the Monte Carlo tree search. So Monte Carlo tree search or MCTS is an artificial intelligence algorithm which is used for decision making in complex environment. The main idea is to simulate many possible future scenarios and evaluate their outcomes. And instead of checking every possible route, that is very difficult, this MCTS algorithm runs multiple simulations, it evaluates the results, it gradually focuses on the most promising routes. So, by doing this, MCTS can efficiently explore very large decision spaces and identify better routing strategies. Now, I would like to call my next group member, Gulsan Kumar Nath, and I over to Gulsan Kumar Nath. Thank you.
So thank you, Vaibhav. So thank explanation. I am Gulsan Kumar Nath and I will explain the Monte Carlo tree search algorithm overall. Okay. Then let's start with a simple idea. Imagine there is a delivery driver and who needs to deliver packages to 5 different locations. There are many possible orders in which the driver can visit these locations. So if you try to check every possible order, that will take a lots of time. So if we have 5 orders from different locations, then it will take around 5 factorial times. So it will be a very time consuming for the large number of orders. So instead of Monte Carlo tree search, instead of using the traditional methods, we use Monte Carlo tree search. That will be a smarter approach. So it simulates many possible delivery routes and checks how good they are. So, for example, one simulation might try the route like from the warehouse we have to visit location A and then location C, location B, and location D. Another simulation might be different, completely different. So coming to every location and every simulations, the algorithm measures things like total distance and delivery time. So our route perform better high scores, best than the better high scores, and while inefficient routes receive lower scores. After many simulations, our algorithm finally gradually learns the optimal delivery sequence works, which works best for our objective. So, in the simple terms, MCTS learns from repeated simulations to find the best decisions. Okay, let's now coming to the slide 7. We have like MCTS works in 4 steps. So, how this algorithm works in 4 steps, we'll discuss now. Coming to the 4 steps, we have the first step is the selection, and then expansion, and then simulation, and at last we'll back propagate and find the best results. So you can think of like learning through trial and error mechanism like this only. So each cycle gives more information about the decision lead to better results. Over time, it becomes very better by promising the best results. Selection. Coming to the next slide, we
अब
have
वो नहीं है,
selection
वो
phase.
चला गया.
And the first step of the
अरे नहीं, कुछ चल
selection,
रहा है, बाद में कर
first
देना.
step of our algorithm is the selection phase, in which the algorithm starts from a root node and which reflects the current situation. In our example, the root node reflects the warehouse where the delivery starts, and from where the algorithm chooses the most promising next locations. So but how does it decide which location is promising? We will decide the location which will give the best results by simulating all the paths. So which will be our next step. So coming to the MCTS, how it exactly using the UCV algorithm. So how it decide that UCV algorithm should be fine for our project, and it's called UCB or UCT. As of you can see that UCB is only for upper confidential band, and those in our project we are using trees methods, so it is called UCT. So this formula balances both the exploration and exploitation. As you know, exploration means we haven't visited the node yet. Like sometimes we visit, but not like every time. So exploitation means we are already performed well in the previous iteration for that node only. So for example, if the route warehouse A to B and it has given the good results before, an algorithm may try it again, but it will also occasionally try new options like warehouse C to D, and it will perform many as per the algorithm. So to see something better exists, this balances both the exploration and exploitation by focusing on good routes. So, coming to the next slide, so we have expansion phase. Next comes to expansion phase. There is a algorithm reaches the node where the node all the options have been explored, and it adds a node in the search tree. Likewise, for example, suppose a driver has already visited a location A, and now algorithm might add a node representing the decision to visit the location B next. So algorithm continues running, the search tree grows bigger and bigger, but each node represents another possible delivery route, so it will be very big. So our simulation phase next comes in this slide number 10. After the expansion, there comes the simulation phase. The algorithm performs the simulation phase and also called the rollout phase. In this case, the algorithm simulates the rates of the routes randomly. For example, suppose current path is warehouse, and where from warehouse to it comes to location A and then location B. The algorithm might randomly complete the remaining deliveries like warehouse A, warehouse B, and warehouse C. Till now we have explored, but after that it can exit to D, C, and E, anything. So this simulation continues all deliveries are completed. Then the algorithm calculates the total travel distance according to the delivery time and routes is efficient. If the routes is efficient, it gives the highest reward. If the routes is inefficient, it gives the lower reward. So this is called our good decisions means our algorithm is making good or bad decisions. Will how we can evaluate that? So we will back propagate from the last node to our root node. So we will be exploring that in our next slide. That how the back propagation works in our next phase. So finally, our our end results maybe might be right or wrong, but we will back propagate and find the best result for our algorithm that will work fine for our project. So once the simulation results is known, outcome is sent back through the nodes to the tree from the to the root node, and every node that is involved in the simulation updates two important values. Like every node has two important values that how many times it has been visited and as the average reward received so far from the simulation phase. So, for example, if we route start from ORS A and consistently produce the good results, it averages reaches means its averages will increase. So, over many iterations, the algorithm gradually learns which routes consistently perform better. As a result, it starts focusing more on the promising nodes. Uh, so, overall transitions is like this, but it has so many drawbacks like any more algorithms can help in that. But in our algorithm, we are transitioning like this. But by exploring the routes over simulating outcomes and learning from the results. Okay. Uh, for my side, this is over, and I would like to hand over Rahul Ray, who will be explaining the more extent to our projects that will add further. Next part, I will like
Okay,
rather
okay. Thank you, Gulsan, for your explanation. Uh, so now let me explain actually how we model the delivery routing problem using Monte Carlo search method. So to apply MCTS, we first represent the delivery problem as a search tree. So in this tree, we first represent the each node is represent a delivery state. So the a delivery state basically tells us three things. So the you can see the current vehicle location, that the remaining delivery location that still need to be visited, and at last the total time or distance that has already been traveled. So from each state, the vehicle has several possible sources for the next delivery location. So this all sources are represented by edges in the tree, and each edge simply represent an action, which means selecting the next location to deliver the package. So to make this more clearer, let's take a simple example. So imagine a delivery vehicle that needs to deliver packages to 5 different locations. So there are many possible ways the vehicle could visit this location. For example, the route could be from location A, then to location B, to location C, to D, then E. But the vehicle could also choose another order like A to C, then C to B, then B to E, then E to D. So each of these routes will result in a different travel time because the distance between the location and the traffic and condition may vary. So instead of trying to manually calculate every possible route, so what Monte Carlo tree method do is it simulates many possible delivery sequences. So over time, the algorithm observes which routes perform better and gradually identifies the most efficient delivery order. Uh, so now let's briefly look at the architecture of our delivery routing system. So our system is mainly consists of four main components. So the first component is the delivery data input system. So this module collects all the necessary information such as delivery location and the package details. Then we come to the second component. The second component is the road network model. So this represents the map of the city, including roads, distance between the location, and the possible routes. So again, the third component is the Monte Carlo Tree Search decision engine. So this is the core part of our system. So it explores different delivery routes and runs many simulations to evaluate them. So, and the last component is our recommendation module. So, after the simulations are all completed, this module selects the most efficient route and recommends it to the our delivery driver. So, in practice, the MCTS engine can perform thousands of route simulation, which helps the system discover better delivery strategies. So, now let's look at the overall algorithm workflow of the MCTS system. So, first we initialize the route node using the starting location of the delivery vehicle. Then next, the Monte-Carlo Tree Search algorithm runs for multiple iterations. During this iteration, the system simulates many possible delivery routes, and each simulated routes is then evaluated, usually based on factors such as total travel time or can be the distance between the two locations. So after many simulation, finally the system compares the results and select the route with the highest reward value, which represent the most efficient delivery sequences. So the because the algorithm run continuously, explore and evaluates new routes, it can gradually improve its routing decision. So this approach helps us find efficient delivery routes in complex situations where many possible paths exist. So that was a brief overview of how we model the delivery problem and how the system architecture works and how the Monte Carlo tree search algorithm operates in this context. So now I would like to hand over the presentation to my teammate who will explain the implementation detail and the experimentation result of our system. So thank you.
Thank you, Rahul, for explaining how Monte-Carlo tree works and how it can be applied to delivery routing. Now I'll be briefly discussing how this approach can be implemented in practice and then conclude our presentation. Coming to the slide 16, the Python implementation concept. In a simplified Python implementation, the delivery system is modeled as a search tree. So where each node represents a possible delivery state. The algorithm repeatedly performs four main steps. So the first one is selection, where it chooses the most promising node. The second one is expansion, where new possibilities routes are added. Third is simulation, where the algorithm performs a random rollout to estimate how good that route might be. Finally, we backpropagate and updates the tree with simulation results. By repeatedly doing this process many times, the algorithm gradually learns which delivery routes are the most efficient. Coming to the slide 17, let's discuss the advantages of MCTS. The Monte Carlo tree search has several advantages. It can be efficiently explored very large route possibilities, which makes it suitable for complex logistic systems. It also adapts well to dynamic environments such as changing traffic conditions. Another benefit is that it does not rely on complicated heuristics, since it learns through repeated simulations. And as the number of simulation increases, the quality of the decision improves over time. So, what the expected results, if implemented in real delivery networks, this system can bring several benefits. It can reduce delivery time, lower fuel consumption, and improve overall road planning efficiently. So, as a result, the logistic companies can operate more efficiently and customers can receive their delivery faster. Coming to slide 19, which is future improvements. In future, this system could be improved by integrating real-time traffic data, machine learning prediction models, and better coordination between multiple delivery vehicles. Dynamic route updates during delivery would also make the system even more responsive and efficient. Finally, to conclude this, in slide 20, delivery routing optimization is a challenging problem due to the large number of possible decisions and constantly changing conditions. So Monte Carlo search provides an effective solution by the simulation-based decision making. By applying this approach, logistic systems can improve route efficiently, reduce operational cost, and delivery packages faster. Thank you for your attention. That's all from our group. Thank you.